day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsiriso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Sabono Discovery Center. Remember, our WhatsApp number is 079 578 2908, grade 12. So you are more than welcome to send your questions to that particular number, or your clarity seeking question, or your solution thereof as we proceed with our presentation. Good luck with your preliminary exam for tomorrow, paper 1. And then today, grade 12, we will be looking at the revision of paper 1 since we are writing tomorrow. Okay, and then we are going to start now with the weightings of content areas that you should expect in your paper 1 tomorrow. So for paper 1, we are having the following topics. That is algebra, and the algebra is carrying 50 plus minus 3, grade 12 on your paper 1 out of 150. And then secondly, we are having functions and graph, which contains 35 plus minus 3 on your paper 1. And then we have finance, growth, and decay, which is 15 plus minus 3. And then we have differential calculus together with the integration. Those takes 50 plus minus 3, grade 12. Therefore, you can see now which topics carry more marks on paper 1. And then now with the paper 1, at the end of your question paper, you'll be having a formula sheet, grade 12. You must be able to classify the formulas that you need for paper 1. Basically, the ones that are starting from the beginning of your formula sheet, that will be for paper 1. So now we have the first class there, which we use for the algebra, functions and graph. As indicated there, you have your quadratic formula, you have your turning point x turning point formula, your y turning point value formula. And then we have the exponential change into log, the rule there, and then that is the condition of that particular conversion of exponential to log. And then secondly, we have the finance, growth, and decay formulas, and therefore we have the A equal to P 1 plus I, or A equal to P 1 minus NI. That means that one is for the simple interest, grade 12. These two are for simple interest, for appreciating and the depreciating value there. And then now followed by the compound interest one. And then we have the A equal to P into 1 minus I to the power N. As you can see now, our N is now an exponent there. Therefore, these two will be for the compound interest calculations. A, if the value it is plus for the value that is appreciating, going up, and then a minus for the depreciating value or reducing balance. And then now we have the I effective. That means it's a formula for the effective rate, which is equal to I 1 plus I nominal. That I on top there is for I for nominal rate, which is the rate that is given to you on your statement when you read your given information. And then we have this M here, and then that M is for compounding. Compounded monthly, that means M will be 12. Compounded quarterly, M will be 4. Compounded daily, 365 days in a year. And then thirdly, we have a third class, which is for differential calculus. For differential calculus, we are having the formula that we call the first principle. And then now that is f derivative of x. Be careful, there's a dash on top there, grade 12, of which you mostly miss it when you write your formula. So be careful, always visit your formula sheet to check that you have copied the formula correctly. And then that says that this is the limit of h approaching 0 of f at x plus h minus f at x, and then over h. Your f at x will always be given to you, grade 12. Yours is to identify the f at x plus h so that you can substitute into your formula to find the derivative of that. And remember, this derivative again is the gradient of a tangent to any function, grade 12. We will look at that as we do the grade the equation of a tangent. And then lastly, on the class of paper 1 formulae, we have the integration, and this one is giving us those rules of integration. So you look at the type of the integration that is given to you, and then you just look at the back of your diagram sheet, which one will be applicable for a specific integration given to you. Okay, and then moving forward, and then now we look at the functions and graph, which were 35 plus minus in your paper 1. And then with the functions, we are having a straight line or a linear function, of which we know that the original equation will be y equal to mx plus c for that one, or you can have y minus y1 is equal to m into x minus x1 greater. That will be your straight line or your linear function. And then the second function, we have a parabola or a quadratic function. And then with the quadratic, we know that we have the formula y. Original is ax squared plus bx plus c. Or it can be y is equal to a into x plus p all squared plus q. Or when you are looking at the equation of this parabola curve, remember, you can also use y is equal to a into x minus x1 into x minus x2 when you are given what? The x-intercept of that particular function. So the third graph, we are having a hyperbolic function. And then with the hyperbola function, we are having y original, which is equal to a over x plus q. Be careful, grade 12 now. Look at x. We are not applying the left and right shifting on the hyperbola. So there won't be any plus q. Plus p. P will always be a 0, grade 12. So in this hyperbola function, we are only considering the up and down movement, which is the effect of q. Okay, moving to the fourth function, we have exponential graph or exponential function. The original, we are using y is equal to a to the power x plus q. Also for this one, grade 12, we do not apply the left and right movement. As you can see that there is no plus p there. We will only consider the up and down one, the effect of q. And then lastly, we are having a circle and semicircle. A circle is the same as an analytical one. We are talking to the graph of y is equal to plus minus the square root of r squared minus x squared. And then when we talk semicircles, we are having semicircle y is equal to, it can be a positive one. Therefore, it will take r squared minus x squared. And then, or it can be a y with a minus 1. And then that is r squared minus x squared. And then what is the difference between the two? If you are having a complete circle, you know that you'll have a circle complete like that. But when you talk to y equal to plus square root of r squared, that means the expected graph now will be only on the positive y value. So it will be half circle on the positive y. And then if it is a negative y equal to minus, therefore it will be a semicircle on the negative axis of y there. Or alternatively, grade 12, you can be given this as x is equal to minus the square root of r squared minus the y squared. Look at that. If it is an x negative, therefore your graph will be on the negative x side. And then the same applies with x plus positive r squared minus y squared. So we are expecting our circle to be semicircle on the positive x side. And then now let's look at the examples now, grade 12. We are given that the g at x function is half to the power x minus 4. And then what is important is you must be able to know your original equations of your graph so that you can easily identify the given ones. And then if you look at the g at x now, since x is an exponent, that means this is an exponential function. And then we are also given h at x is minus x minus 4. Therefore, this is a straight line graph or a linear function. Now we understand the given graphs. Now we can now look at the questions. The first question says, is g an increasing or a decreasing function, grade 12? Now, if we refer to g now, we refer to the exponential function. If we are given two graphs, grade 12, be careful when you read your question. Is the question referring to g or an h graph? Be careful on that one, because you can end up answering in terms of h wherever you are given in terms of g. Okay, this is g an increasing or a decreasing function. Okay, and then now you need to understand now your function that is given to you. In this case, you are given g at x is equal to half to the power x. So this half, remember, it can be written as 2 to the power negative 1. And then this will end up being negative x minus 4. So if you try to predict the sketch of this function, your arm will be away where x is negative. That means from the second quadrant there, going down and so forth. That is basically the graph, because it has shifted 4 units downwards according to that. So basically, this is the graph we are expecting because of x being negative there, and remember our y is positive. So it will be an arm up in this quadrant 2 where x is negative and the y is positive. Basically, grade 12, you can see that from left to right, the graph is decreasing. So that is how we are going to identify that, and it's only 1 mark. So this tells us that grade 12, you need to know the original sketches of your exponential function in all quadrants, all right? And then number 2, write down the equation of the asymptote of g. We are still on g again. Okay, remember, an exponential function is having only one asymptote. The hyperbola is the one that is having 2, which is x always equal to 0, and the y depending on the value of q. But in this case, with the exponential one, we are having only one asymptote, which is the horizontal one. Because now our graph are having an arm that is continuing to positive infinity, continue to negative infinity. So there is no way that you can have a vertical line that is blocking your graph, grade 12. Hence, we are only relying on the horizontal, which is the Q1. So in this case now, that means your asymptote will have a relationship with the Q value. So now, since it's the horizontal one, horizontal, look at me, I'm cutting the y-axis. Horizontal, cut the y-axis. Then my asymptote will always be y equals to, because I am talking to the horizontal one. So in this case, our q is equal to minus 4. Therefore, it will be y equal to a minus 4. Then we have 1 mark for that grade. And then moving forward to number 3. In number 3, they say determine the x and y intercept of g. Okay, we are still on the g function. We now want to identify the x and y. The method doesn't change, grade 12, in all the functions. When you look at x intercept, you let y equal to 0. So on which function now? On a g function. So this is our g function. We let y equal to 0. And then we have half to the power x minus 4. Next step, we transpose minus 4 to the left, grade 12. It will be positive 4. And then we have half to the power x this side. Okay, you can apply your logs and say log 4 base half, or you can have the same bases, raise your left and right side to same bases. So we can have this 4 as 2 to the power 2. Remember, we said half is the same as 2 to the power minus 1. So this can be written as 2 to the power minus x. Therefore, we end up with 2 equals to minus x. Therefore, x will be negative 2. When you are applying your logs, grade 12, from this step, remember you'll be having the log of 4 with the base of half. Therefore, this will definitely give us the same answer, which is x equal to a minus 2. That is the x-intercept for the g function. And then to find the y-intercept of g, we're still going to let x equal to 0 because that is the application within all functions. And then we have our g function, which is y equal to half to the power x. Our x now will be 0, and then minus 4. Half to the power 0 is 1, and then a 1 minus 3. Minus 4 will give us a minus 3. Therefore, we have y-intercept as minus 3, and the x-intercept there as a minus 2. Then the allocation of marks grade 12 is 4 marks. 1 mark will be for substitution of 0 into the equation of g, and then for simplifying until you get a minus 2. The third mark will be for substituting x with the 0 on your y-intercept, and then finding the y equal to minus 3. That is how the 4 is allocated. And then now, question number 4. Determine the x and y intercept of an h function now. That means we will be using the h at x to answer this question. Same application, same method. We want x-intercept. For the h function, we let y equal to 0. So into h, y, you are 0. And then minus x minus 4. We transpose an x, becomes a positive x. And then we left out with x equal to a minus 4. That is the x-intercept for the h function. And then to get the y-intercept, we now let x equals to 0. And then there we are. We go into our formula for the h at x function. We now change h at x to y because it's one and the same thing. And then equal to x is 0 now. Minus 4. So we end up with y equal to minus 4 as our y-intercept for h at x. And then now the next question, 5, grade 12. Okay, and then now for question 4, it's 1 mark for the final answer, 1 mark for final y value. 1, 1, 1 for x value, 1 for y value. And then now we come to number 5, where we are sketching those two graphs on the same set of axes. Right, remember you are having an asymptote there for the g function, which is y equal to minus 4. So we are going to start by writing off that asymptote minus 4. And then we have the x-intercept. We are now concentrating on g first. G is having x-intercept minus 2. There you are, you have a minus 2, that is an intercept. And then we have a y value, there we are, which is minus 3. So we go to y, 1, 2, 3, there we have a minus 3, that is an intercept. Okay, and remember you have identified somewhere there that the graph will look like that. So we are going to sketch our graph. Ensure that your graph does not touch the asymptote grade 12. It is coming closer to the asymptote, but it will never ever touch the asymptote. And then now moving to the h at x function to sketch that one. We are having x minus 4, minus 3 minus 4. And then we have the y, which is minus 4. That means on top of that asymptote, now we have a point for the h at x function. So it will be minus 4 and minus 4. Therefore, this is the line that will be having grade 12, because that is a straight line going up like that. So that is the straight line function expected. And as we can see that the gradient is negative there, that is why our graph is a decreasing function. Because m is less than 0, meaning m is negative from the given information. Those are additional questions that examiner can ask you. Is the graph increasing or decreasing, and so forth. And then if you look at this, remember you have indicated also that the g is a decreasing function. Since it is decreasing, it means also the gradient for g is a negative gradient, grade 12. Okay, and then moving forward to the next activity there, we are given f at x equal to minus x into x minus 2 squared plus 4. Remember, it is very important to know your functions. Number one, before you can attempt any questions, we are going to check which type of a graph is that one. Since we have exponent 2 there, therefore it's a quadratic one. Remember, quadratic is ax squared plus bx plus c. Exponent 2 is quadratic. Okay, there we have a quadratic function. So the first question, determine the x-intercept. The method is not changing grade 12s in all the functions. To find the x-intercept, you let y equal to 0. So we are taking our f at x function. For f at x, I will change that to y. And this is minus, and then now, y is 0, sorry. So we'll substitute immediately 0. And then we have minus x minus 2 squared plus a 4 there. Okay? And then now we transpose this part, which is negative now, to the left. This will be positive x minus 2 squared equals to a 4. And then if this side loses an exponent 2, this will gain plus minus the square root. That means this will be x minus 2 equals to plus minus the square root of 4. That means we are having two solutions grade 12, which is a plus square root of 4 and then the minus square root of 4. So let's separate that. We are having x minus 2 equal to the positive square root of 4, which is positive 2. Or we have x minus 2, which is equal to the negative square root of 4, which is minus 2 now. Okay, and then this gives us the solution, x equal to, the negative 2 comes to the side, become positive. 2 plus 2, 4. Or we have x equals to, transposing minus 2 to the side, positive 2 minus 2, then this one gives us a 0. Those are the x-intercept of that particular function. And then this with 3 marks, grade 12. And then 1 mark will be for substituting a 0. The second mark will be for factors. And then the third mark will be for both x values. Therefore, this is worth 3 marks. Okay, remember it depends on the examiner how many marks he or she wants to allocate to that particular question. And then number 2, write down the y-intercept of f. Look at this, it says write down the y-intercept of x. That means your answer is somewhere there, grade 12. And then now, remember, you can't find the y-intercept without letting what? X be a 0. So you just put a 0 there for x, and then you put everything into your calculator. That means it will be y equal to minus 0 minus 2 squared plus 4. And then into our calculator, grade 12, straight to the answer. This will be just a 0. Then 1 mark for having an answer equals to 0 then. And then moving forward to number 3. Our number 3 says write down the coordinates of a turning point. Again, we are just writing down. Write down, that means your answer is there on the given information. So now we are looking at the turning point. Remember, this graph is the type of y is equal to a into x plus b squared plus q. And we always say our turning point for this type of an equation is our p and q there. Hence, the question says write down. So that means we are just going to take it from our equation. As you can see that if it is minus 2, it will be a positive 2 here. Remember, x is always abnormal, okay? And then the q value always talks to what is on the equation. If it is positive, it will remain positive. But be careful of this x value. If it's a minus 2 there, that means it was initially a positive 2. Okay, right. And then now number 4 can sketch the graph. For this one, you'll be having 2 marks, 1 each for the trap. So this will be worth 2 marks. Question number 4, the graph of f. Sketch the graph of f. Clearly show all intercepts and the turning point of your graph. That means all your calculation must now appear on the diagram. Don't assume that you have calculated them somewhere, so we must automatically know which value belongs to which part. So you need to clarify and show all the intercepts and the turning point on the graph. Let's start, great jobs. We are having the x-intercept, which is 4 and 0. 0, we have an intercept at 0. We have the x-intercept again at 4. And then we have the y-intercept again at the same point as the x-intercept, which is 0 there. And then we are having a turning point at 2. This is coordinating 1, 2, 3, 4. Remember, it's a pair now, it's a coordinate, it will be 2 and 4. Where they meet, they form a point. This one are sharing now. So we will be having now, the graph is negative, it will be concave down shape. So it will be going there, going there. It will go like that. So that is the particular graph for that specific formula given to us. And then number 5, write down the range. Remember, when we range, we are talking the y values that lie on the function, okay? And then as we can see that the maximum value for this function is at what? At y equals to 4. There is no way that this graph can go beyond that point. So that means we are taking all the y values starting from 4 going down, because this is going to negative infinity. And then how do we note this down, grade 12s? Number 5, we are talking at y. If we go down, we go less, but 4 is part of the solution because it's your turning point. That is why we are putting an equal sign to show that we have included 4 in our solution. Therefore, this will be less and equals to 4. Or another notation, we can have y is an element of our y is starting from 4, and 4 is part of the solution. Therefore, it's a square bracket starting from 4 going down. Okay, you must always start with the smaller one. That means it will be y is an element. Remember, we are going to the negative infinity. So negative infinity is smaller than 4. So this notation is very important. You need to check. You start with the smaller number. In this case, it is the negative infinity. And the negative infinity, we cannot include that. So it cannot take the square bracket because it's not a specific value. So that will take a round bracket, negative infinity, and then followed by the maximum value 4. Because 4 is part of the solution, then it will take a square bracket. I hope grade 12 we are still together on this one. Continuing to the next graph, we are given f at x, 2 over x plus 1. Identifying the graphs is very important. Therefore, if you look at that, x is now a denominator. Therefore, that must be a hyperbola graph. And then on the G1, x is an exponent. That means that must be an exponential function. Being able to identify your graphs is very important, creators. And then now, first question, write down the equation of the asymptote of f. We are referring to f function now. We need to identify the asymptote. Remember now, with the hyperbola function, yes, we have 2 asymptotes, but the first one is fixed, the one for x, because we do not have shifting of the asymptote, shifting on the x-axis. That means it will remain at x equal to 0 for all your hyperbolic function. The first asymptote will remain being x equal to 0. It's a given one, grade 12, that one. It is always like that throughout all your hyperbola functions. And then now the second asymptote will be y equals to, depending on the q value now, that will be y equals to 1. Therefore, it's 1, 2 marks for your asymptotes. Moving forward, number 2, calculate the coordinates of the x-intercept of f. We are still on the f function hyperbola. We are now calculating the x-intercept. X-intercept, you know the method now, grade 12. You let y equals to 0. So y is 0 equals to 2 over x plus 1 because we are looking for the x-intercept. Next step, grade 12. Yes, we transpose 1 to the left. This will be minus 1. Then we are left with 2 over x. The next step, grade 12 thereof, you cross multiply this x to that minus 1 on top there. Then we'll be having minus x on the left equals to 2. Therefore, x is equals to negative 2. That is your x-intercept. How much does it worth? 2 marks, 1 for substituting a 0 and 1 for the answer. Question 3. And then sketch the graph of f and g on the same system of axes. Okay, right. Let's see now. Do we have anything for g at x? No, but greater, this is a basic graph of g. Let's start with the f first. Let's sketch f and then we'll talk to the g after. And then with the f function, remember we are having asymptote at x equal to 0. That means that asymptote is on top of this y-axis here. Remember the line x equal to 0 is the y-axis. The line y equal to 0 is the x-axis, creatures. And then now another asymptote is at y equal to 1. So we have a horizontal asymptote at y equal to 1. The vertical one will always in all your hyperbola be on top of your y-axis there. And then we have x equal to minus 2. 1, 2 as our x-intercept. So grade 12, it is very important to be able to identify the shapes of your graph. Remember the shape rely on the value of a there. If a is positive, we are expecting this graph to be in quadrant 1 and 3. If it is negative, it will take 2 and 4. Okay, right. And then now, according to this prediction that we are having here, that means our first arm will be there, coming closer to the y-axis, but do not touch that. And then another arm will be a free arm on quadrant 1 there. So that is the f function expected from us. And then now looking at the g function now. G function, you can use a calculator method for those who are familiar with that. And then if you are not, you must start always with the asymptote. Now for this one, the asymptote is also at what? Y equals to 1. Remember the exponential is having only one asymptote, which is the horizontal one. So that means these two graphs are sharing the same asymptote at y equals to 1. Okay, great terms. And then now remember 2 to the power x, if you put a 0 there, that will be 1 plus 1. Therefore, this graph will cut at 2 there. So if you look at this, x is positive and y positive. In which quadrant is x positive and y positive? That is quadrant 1. So your arm will be up in that quadrant, going closer to the asymptote without touching the asymptote. Okay, positive y, positive x. That shows the arm in quadrant 1 where y is positive and x positive. It's where your graph starts there, away from the axis. Going closer to the asymptote, it must not touch this asymptote. Is for both conditions of graph G and F. Okay, and then write down the range of G. Remember, this is F function, the hyperbolic one, and then the G function. When we talk to G, we are talking to the exponential graph. What is the range for the exponential graph? This exponential graph will never ever go below this point, below the asymptote y equals 1. It is immediately above that point going up to positive infinity. That means if we want to check the range for that one, we are talking y greater than, because it's going up, positive y values. So it is greater than which value? 1. Can we put an equal sign and include 1 on this one? No, because 1 is an asymptote. It is not part of your equation, okay, of your graph. It is everything immediately after 1 going upwards. Or another notation, we can use that other notation. Y is an element considered a smaller number. Now, in this case, it is starting from 1, remember, going up, immediately after 1 going up. Then because 1 is not part of our solution, we put a round bracket starting from 1 going to positive infinity, and then infinity also takes a round bracket, grade 12. Please be careful of this notation. Bracket must be 100% correct, and then it must start with the smaller number and then the bigger one after that. Okay, now we move to semicircle and the exponential graph again. The graph of a semicircle defined by h at x, look at that, grade 12. It's a positive semicircle and it's a y equal to, that is why our graph is on the positive y side. It relates to the formula that is given to us, okay? That is centered at the origin, so we have a center origin is 0 there. And the exponential function defined by g at x equal to 2x plus q are drawn. So this is our g function as indicated there, and then this is our h function as indicated. So that is a semicircle. You must be able to identify from the formula. This one is an exponential one. Even if it was not indicated to us, the grade 12, you must be able to identify them. And then now we are given A and B. We are talking to this point here. Are the x-intercept of h function of a semicircle. All right. And then we have points 0 and 2. And C minus 73 over 15k. Those are the point of intersection of the two graphs. As you can see now, grade 12, it is where the two graphs are intersecting. And then the horizontal asymptote of g at x cuts the y-axis at q. Okay, determine the coordinates of A. Remember, we don't know the value of q yet. We'll look at that later on. So now, as it is given in terms of q, there's no specific value for that. And then now, the coordinates of A and B, that's our first question to address there. Coordinates of A and B, colleagues. Grade 12, can you do that for me? Remember now this 4 here. Our initial equation is saying the square root of r squared minus x squared. That simply means now, grade 12, this 4 is the value of what? Of an r squared, since it is substituted in the place of r squared. Therefore, what is the radius of this particular semicircle? It will be plus minus the square root of 4, which is plus minus 2. Okay? And then now the radius, remember, is from the center of a circle to the circumference. This simply means now for A, we are having coordinates what? Since it's on the negative, it will be minus 2 and 0 there. And then for B, same distance from center to these 2 units, therefore it will be 2 and 0 for B. As easy as that, grade 12. So now, since it is needed in coordinate, it must be written in coordinate. A minus 2 and 0, and then B as 2 and 0 there. Then 1 mark for that, 1 mark for the second pair. And then now, number 2, the numerical value of Q now. Remember, Q is in the graph, Y is equal to 2 to the power X plus Q. That means we are talking to an exponential one, which is a g function. So if we check on g, we have a point with both coordinate values there, 0 and 2. So we can use this particular point now as our x and y substituted into our equation so that we can find the value of q. Okay, if you have an unknown, check in your graph, do you have a point that you can use to substitute for x and y in all the functions, grade 12. Therefore, y in this case will be 2, and then our x will be 0, and then we have plus q there. Still we have 2, and then 2 to the power 0, it's 1, and then we have plus q. When you transpose 1 to the left, it will be 2 minus 1, which is 1. Therefore, our Q value here is just a 1. Okay, so if you want to write this equation again now with correct values, it will be the G at x equal to 2 to the power x plus 1 now. That simply means this graph have shifted 1 unit up. As you can see, it moved away from the x-axis now. It's 1 unit up. Okay. And then now looking at number 3, the equation of a straight line. Determine the equation of a straight line passing through B. Remember, we now have coordinates of B as 2 and 0 there. And then through a point 0 and 2, which is that point. So we are taking a line that is passing through there, going there like that. So that is the straight line we want to find the equation of. So grade 12, remember, with any straight line, in order to find the equation, you need a gradient and a point on that particular function. And then now if you look at this straight line, we do not have a gradient, so we need to start and calculate the gradient. And then let's do so now. We have m equal to y2 minus y1 over x2 minus x1. We will be relying now on 0 and 2 and the b value there. Okay. So if you decide this will be your family 1, both of them must be x1, y1. If you decide this one is x2, both of them must be 2's then, x2, y2. Let's now substitute. We are having m equal to what is y2? 2 minus y1, 0, x2, 0, minus x1, 2. So this is giving us 2 minus 0, which is 2, over 0 minus 2 minus 2. So our gradient is negative 1. Always relate your answers to the graph. As you can see, it's a decreasing function. That is why our gradient is negative, because the graph is decreasing, grade 12. So we are 100% correct. And then from here, we are not yet done, because we are looking at the equation of that particular straight line. Now, since we have a gradient, you can choose any point. So let's say we are taking 0 and 2 now. And then we have a gradient which is equal to minus 1. And then we go y is equal to mx plus c, which is the straight line original. And then we want to find the value of c now. This will be our x, this will be the y. So for y, we are going to substitute a 2. Gradient, we have minus 1. For x, we substitute a 0. The aim is to find the value of c. If you can have that c value, therefore, we will be happy now. We will be having our equation. And then now we end up with the 2. Negative 1 times 0 will give us the 0. Therefore, c is equals to 2. So therefore, our final equation. Now remember, with an equation, you must leave your y and the x because it's an equation. Okay, so we leave y. We substitute m, which is minus 1. We leave x. Remember, there's the 1 there. And then we now add the value of c, which is 2. So basically, this is the equation of that straight line. And correctly so, look at that. It is cutting at 2 at y. Can you see your y-intercept will be 2 there? If you let x equal to 0, yes, grade 12. Always relate to the graph whether your calculations are correct. Okay. And then the next one, that will be your activity, grade 12. 5 minutes. Starting from now, please answer that particular question for me. Thank you. Okay, grade 12s. Let's see how far did you go with this one on your own now. It states that the graph defined by f at x, which is equal to a over x plus q. Remember, you must know your functions by just looking at the equation. Therefore, this is a hyperbola graph, okay? And then the graph cuts the x-axis at -2, as you can see on the diagram there. This is cutting at -2. And then look at the diagram again. You have another given information that your asymptote is equal to 2. Therefore, y is equal to 2 is your equation of the asymptote, the horizontal one, horizontal. If the examiner asks for horizontal asymptote, you must know horizontal, you go this way. As you go this way, look at you are cutting what? The y-axis line. Therefore, is the equation y equal to for horizontal. Okay, I hope you'll remember that. And then now determine number 1, the numerical value of q now. Okay, in order to find q grade 12s, you look into the diagram. Can you see that is already given? So this question can be a write down the value of q because the answer is in your diagram. Therefore, the q will be equals to 2 because q is your horizontal asymptote. I hope you are still together there. Moving forward, so it's only 1 mark for that, correct? And then number 2, the numerical value of a now. We now have a q, we have y for f at x, and then we have a over x plus q. Our q is now positive 2. And then from there, we want to calculate the value of a. Look at that. That means we need something to substitute for x and y there. So go to the diagram and check, can you have a point which will give you an x and y? So if you look at this point here, we can write that in coordinate form. It will be -2 for x and a 0 for y. Yes, we can rely on this point as our x and y. So how much is y? Y is 0. We are looking for a. X is -2, and then we have a +2 for q that we calculated in number 1. And then we are going to transpose 2 to this side, it becomes -2. Same method as previously, grade 12s. And then we have a over -2. Cos -2 to 2 -2 there, we end up with -2 times -2, which is positive 4. Therefore, the a value will be just a 4. Okay, so this equation is actually y equal to the real equation. So a is equal to 4, that will be 4 over x, and then plus a 2. That is our actual equation of that hyperbola function. Okay, as we can see, our a is positive. It guarantees, it matches the diagram because it is in quadrant 1 and 3. Okay, always check your calculations. Does it relate to your graph correctly so or not? Okay. Moving now to number 3. So the mark allocation here, it will be for substituting the value of q, x, and y, and then for finalizing that a is equal to 2. So number 2 with 2 marks, grade 12s. Okay. And then now, number 3, we have the equation of the asymptote. Determine the equations. As you can see, we need 2. It says equations, that means it's more than 1. Hyperbola, remember, is having 2. Exponential is having 1 asymptote. Okay. And then now we need the equations of the asymptote of f. That means you are looking at the x equal to and the y equal to. Remember, I said to you, x is always the bonus. It will always be x equal to 0 because we don't have any shifting on x. And then the y is taking the q value. Therefore, is y equal to 2. And then grade 12, if they request the equation of the asymptote, do not write p equal to 0 or q equal to 2. We need that in terms of x and y because they are equations. Okay, in terms of x and y. All right. 2 marks, 1 for x, 1 for y. Therefore, this was 2 marks. Number 4, the domain of f. Domain, we are talking to the x values that lies on the function. The x values that lie on the function. All right, great job. And then now we can take a horizontal test line. Remember, you have an asymptote here. X equal, that is hidden on top of your y-axis there. Okay, that one is of x equal to 0. It will always be like that throughout all your hyperbola function. Now we want to identify the domain. Domain, you can use your ruler as a vertical test line and then move around your graph. So if we move to the left, you can see the graph will be continuing to us up to infinity. Nothing is blocking us. But the minute we come back greater, we have an asymptoted x equal to 0. We can't touch that point because it's not part of the solution. The minute we reach 0, we will skip the point 0 and then to the other side of positive x values, and then immediately after 0, positive values up to infinity then. That means if it wasn't of the asymptote x equal to 0, we will be saying x is an element of all real numbers. Isn't it so, okay, Charles? But now we have a challenge with only x equal to 0 because it's an asymptote. That means the presentation will still say x is an element of real numbers, but x must not be equal to 0. We will only exclude the asymptote. Therefore, that is the domain for that particular function. So if the examiner was also looking for the y, let's see now if we're having a question saying the range now on the same graph. If we range now, we move along the y-axis line. So when we move down, we can see that it is going to the negative infinity, okay? But when you move up now, you are stuck at 2 because 2 is not part of your graph. You need to skip a 2 and start moving again immediately after 2, moving up to positive infinity. So if it was end of 2, we will be saying y is an element of real numbers, but in this case, we will exclude a 2. Y must not be equal to a 2. So y will be element of real numbers. Y must not be equals to 2. And then look at this relationship, creators. The values that we are excluding there are exactly your what? Your asymptote. Okay? So the domain and range of a hyperbola graph, they will always remain x element of real, y element of real numbers. But what we are changing is the asymptote because we will be excluding asymptote according to the particular graph. Okay, so I hope we are still together then. It is always x element of real numbers excluding the x asymptote, y element of real number excluding the y asymptote. Moving forward, the next activity 2, grade 12. Again, this is for you. And then please spend 5 minutes on that one and reflect back the solution. Your 5 minutes start now. Okay, grade 12s. Let's see how far did it go. Please mark yourself as we continue with the solution and check how many marks can you get on your own now. Okay, the question says that the graph represents h at x equal to minus x squared minus 3x plus 10. As you can see, this is a parabola graph. And then the g at x equal to mx plus 10, which is a straight line one. Okay, and then which intersects at point A and C. Let's look at the diagram now. They are saying they are intersecting at A and C. That is true, as you can see on that particular diagram. Okay, the points A, B, and C are the intercept with the axis of h at x. What is h at x? It's a parabola graph, concave down there. So they say A, B, and C are the intercept. As you can see, A and B is the x-intercept, and then C is the y-intercept of that particular function. And then D is the turning point. Yes, we have D point there at the turning point of h at x. Now, number one, you have to determine the coordinates of A and B. I think they have already given you a direction by saying AB is the intercept. So we will be applying the intercept method using the h at x equation because A and B are the x-intercept of a parabola function. So let's do so, grade 12. Look at the x-intercept of the parabola. We let y equal to 0. And then now substitute for the y value, we put 0. And then we have the minus x squared minus 3x plus 10 equation. Multiplied throughout by a negative, we end up with 0. X squared plus 3x minus 10. So we are looking at the factors of 10, grade 12s. Remember, factors of 10, we have 1, we have 2, we have 5, and also 10. Those are the only factors. And then now, how can we get a product there? It will be 1 times 10, 2 times 5. And then this statement is saying to us, look at the factors of 10. When you subtract them, you get what? You get a positive 3. When you subtract them, factors of 10, there you have them. When you subtract them, they must give you a 3. That means which pair qualifies to be there? That means it's 5 and 2. In order to have a plus 3, that means the bigger one must take a positive sign. Therefore, grade 12, that is how you identify your factors. All right, moving back to our trinomial factor now. We are going to have x minus 2 and x plus 5. Check. X times x, x squared. X times 5, 5x minus 2x, that is 3x, minus 2 times 5, that is minus 10. That means those factors are 100% correct. And therefore, the first bracket will give us x equals to 2, or x is equals to a minus 5. Grade 12, you are more than welcome to use your quadratic formula for factorization where you have a challenge of applying the short method. No penalty, full marks for that. Okay. And then now remember here we are answering the coordinates of A and B. We are not yet done, grade 12. You need to give us the solution in terms of coordinates. And then now relating to the diagram, look at A. A is on the negative x values. That means it is the one that is going to take the negative x value, which is minus 5, coordinating with y 0. And then now the B will take the positive 2 with the 0 there. Therefore, this problem worth 3 marks. So it will be 1 mark for factors, 1 mark for the coordinate of A, and 1 mark for the coordinate of B. This were 3 marks. And then question number 2. Determine the coordinate of C. Look at C. You relate to the diagram, grade 12, in order to decide which way to take in terms of solving the problem. If you look at C there, C is the y-intercept for both functions h and g, okay? And we know that when you look at the y-intercept, you let x equal to 0. So if we take h at x and let x equal to 0 there, can you see that y will be 10? The same applies when you go to G function. If we let x equal to 0, remember multiplication by 0 eliminates the product, all right? That means it will be m times 0, which is 0 there. Can you see you're left with y equal to 10 for both conditions? So that means you can use any of the two now. Let x equal to 0 there. So this basically will give us a c coordinate of c being a 0 for x, and then we have 10 for y from the equations there. Okay. Number 3, the coordinates of the turning point D. So we have 3 ways of doing it, grade 12s. Number 1, remember we are relying on the h at x because we are looking at the turning point D. D, as you can see, is on the h function. So now you have the formula on the formula sheet, which says that x is equal to minus b over 2a. And then we substitute the b value from original, not the simplified equation. From original, that will be minus, how much is b? It's a negative from the formula first. And then the b value is also negative. That is why we are having 2 negatives there. Negative for the formula, negative for the value of b. Over 2. And the value of a is also negative 1 there. Put a negative 1. So this will give us basically a minus 3 over 2 when we put that into your calculator. That is the first way of finding the x turning point. Or secondly, if you don't use that method, you can use the analytical geometry midpoint. So now remember we have a here as being minus 5 and 0, and then b there as 2 and 0. And then if we look at the x turning point, we are taking the middle point of the two. So with analytical, remember when you did midpoint, we will say x1 plus x2 or x2 plus x1. That will be minus 5 plus 2 divided by 2. Can you see grade 12? You still end up with the same answer, minus 3 over 2. This one is only applicable if you have your x-intercept. Okay. Lastly, grade 12, you can apply your calculus. Remember, a derivative is a stationary or turning point. So you are going to start by deriving your h at x function, which will give you minus 2x minus 3. Let it equal to 0. Transpose minus 2. Divide by 2 both sides. So x is minus 3 over 2. Same answer for all conditions, okay? Then you will choose the one that you are comfortable with. And then if you have an x value now, you can substitute into h at x and put in a minus 3 over 2 wherever you will be having an x. And then this one will give us the y value that is equal to 49 over 4. As you can see on the diagram, y is positive and then the x value is negative. So this correlates smoothly with the graph. So now conclude now, turning point or the D point will be having the x value minus 3 over 2 coordinating with 49 over 4. You can write this in any decimal form. Okay, fraction. You can write as fraction, simple fraction, combined fraction, or decimal fraction. It's up to you, grade 12s. And then moving on now, the last question, you are looking at number 4. Number 4 says determine the value of m. M, if you look at m, is the gradient of that straight line graph. So we have 2 ways of doing this, grade 12s. Number 1, you can check on that line, AC. Do you have any point that you can substitute for x and y so that you can get an m? Yes, you can use A or you can use C because we have coordinate of C as being 0 and 10 there. Can use any of the points. Let's say this learner decided to use A. So that means for y equal to mx plus 10, substitute 0 for y, and then we have m. And then x is minus 5 plus 10. Okay, then this will give us a 0 minus 5m plus 10 Transpose minus 5 becomes a positive 5. M equals to 10. Divide by 5 both sides. Therefore, M is equals to a 2. That is the first question. But this one will not give us the solution grade 12 if you choose 0 and 10. Because if you put an x 0 here, it will eliminate the x that we are looking, the m that we are looking for. So we can't use x equal to 0 to find the solution here. So C will not work for us. Or alternatively, we can go the gradient normal way, where we are looking at m is y2 minus y1 over x2 minus x1. If you decide this is family 1, this is family 2, it's fine. So y2 will be 10 minus y1 0, x2 0, minus x1 plus 5. Look at that grade 12, we have 10 over 5, which is still a 2. So that will also still give you the correct answer. Okay. And then now this brings us to the end of the functions grade 12. I hope everything was clear to us in terms of the functions now. Okay. And then moving forward to the next topic on paper 1, we are looking at differential calculus. This word 15 plus minus on your paper 1. And then with differential calculus, what is our expectation? We will be expected to apply the first principle to determine the derivative of a function. And then when you talk first principle, you are talking the formula f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x, and then everything over h. Remember, the formula will be given to you at the back of your formula sheet. Don't stress about claiming the formula grade 12. It is there, back of your formula sheet. And then we have, secondly, the rules of differentiation. That will be the question after first principle. Application of the rules grade 12. For example, if you are given y is equal to ax to the power n, when you derive this will be dy dx equal to, it's a multiplication of n there, that will be n a x, and then on the exponent we subtract 1. That is the basic rule of differentiation. And then moving forward, we have the average gradient and the equation of a tangent. Remember, when you talk average gradient, we still talk to the normal gradient that we know that y is y2, m is equal to y2 minus y1 over the x2 minus x1. That means you need 2 points in order to be able to calculate that average gradient. 2 points with coordinates, right? And then the equation of a tangent. Remember, a tangent is a straight line. So we still use the same method. We are using the y is equal to mx plus c. The same way that we used when we are looking at the equation of a straight line. You need a gradient and a point. If I can have a gradient of that tangent and a point with x and y coordinate, then I will be able to find the equation of a tangent. But for this case, because it is under differential calculus, to find the gradient, we will be relying on the derivative of the particular function of which it is a tangent to. Okay. And then we have cubic function. And then with the cubic function, remember, is the graph of y is equal to ax cubed plus bx squared plus cx plus d. That is the original equation for a cubic function. And then when you apply, we want the equation, we use y is equal to a into x minus x1 into x minus x2 into x minus x3 when you are given the intercept of that cubic function. Okay, and then now look at the optimization and the calculus of motion. With optimization grade 12, we will be applying the same method that we do when we look at the stationary point. We will be using the area of the shapes, the total surface area of the shapes, the volumes of the shapes, and then the perimeter of the shapes. That means we are talking our cylinders, our box, our cones, our spheres, our hemispheres. So In order to master optimization, you must ensure that you know all those formulas and which one to apply when. And then that is the application of optimization. So we will be deriving to look at the maximum and the minimizing of the optimal problems. And then the calculus of motion is having the relationship with the distance covered at a certain time, the velocity at a certain time, and the acceleration at a certain time. So when we talk the velocity, we are talking the derivative of the distance covered. When you talk acceleration, we are talking the derivative of the velocity. And remember, velocity is the derivative of a distance, so we can say second derivative of a distance is an acceleration. Great job. So let's see how far can we go with calculus then. So we are having the first principle formula. Remember, I've already indicated you'll find the formula on your formula sheet. So if you look at this, in order to find the f derivative, which is the gradient of a tangent to a function, and then now you need f at x plus h and the f at x. So f at x will always be given to you. Yours is to find f at x plus h before you substitute into your derivative formula. Now, let's look at the first example here. Determine the derivative or the gradient of a tangent using the first principle if f at x is equal to 5 minus half x. So grade 12, your answer will always be the coefficient of x. Your final answer, you can predict your answer by looking at the f at x equation that is given. Your answer in this case will always be the coefficient of x. So we are expecting our f derivative to be a minus half. Let's see, is it true, grade 12? Remember, the method says look at f at x plus h first. We are looking at f at x plus h. This simply means now where we are having an x in our equation, we are going to substitute x plus h, which is equal to 5 minus half. Now we have an x. Okay, this will be x plus h. Okay, and then now moving on, we have 5. We are now multiplying half into both x and h. So we'll end up with minus half x minus half h. Okay, remember this is now our f at x plus h. Happy now, we have f at x, we have f at x plus h. We can now move into our derivative formula. F derivative is equal to the limit of h approaching 0 of f at x plus h minus f at x all over h. Grade 12, be careful. Equal sign must be before your limb, not after the limb. Notation mark. Please, you are going to lose a mark if your notation is incorrect. The division line starts from f at x throughout f at x plus h to f at x. Not cutting off the limit, okay? Right. And then from here now we can now substitute. We continue writing the limit of h approaching 0. Substitute your f at x. We are taking the f at x from there, which is 5 minus half x minus half h. Minus. We put an important bracket there because we are having two terms for f at x there. That is 5 minus half x. This bracket plays a major important role, grade 12. Ensure that you have a bracket because this negative will affect both terms inside your bracket. And then remember your h denominator, grade 12, which is sometimes missing from your calculation. Take care of that h. And then you are having limit of h approaching 0. Now on this step, we want to deal with this negative now into the bracket, right? So we write this ones as they are, minus half x minus half h. And then multiply negative in now. Remember, you have a negative 1 there. Minus 1 times 5 is negative 5. Minus 1 times minus a half, it's a positive half x. Everything over h. Right, grade 12. And then what must happen is that whatever you are having as of f at x here, it must disappear at this stage. there must be something cancelling. If there is no cancellation, you must know you are going wrong, okay? Half x minus half x. Can you see that? Minus 5 plus 5. Whatever was having, they have now been cancelled. And then we have the limit of h approaching 0. We are now left with minus half h from there. And then over h. The h will cancel in h. So our answer, grade 12, is minus half. The minute we have something without an h, we don't write this lim anymore. This lim h approaching 0 must appear throughout where there is an h. There must be a lim on the left. The minute there is no lim, no limit of h approaching 0. Where there is no h, no h, no lim of h approaching 0. Okay. And then the second example, let's look at this. What is the expected answer? Remember, I indicated to you how to predict your answer, okay? Coefficient of h will be, the coefficient of x will be your answer. Can we predict the answer for number 2? Yes, the coefficient of x is minus pi. Therefore, our derivative answer here, we're expecting it to be a minus pi. Now, grade 12, remember pi is a constant number. We approximate it to 22 over 7, okay? So now, since it's a number, we will treat it so. Right, we are looking at f at x, which is what is given to us. Remember, you must check the f at x plus h before you go to the formula. Oh, we have x, we have x. So wherever we have an x, we are going to substitute with x plus h. There you are. You have a pi minus the pi. Because there's an x, this is now x plus h. I hope you are still together, grade 12. We are busy looking for the f at x plus h, pi, and then we are now multiplying this pi in each of this x and h. That will be minus pi x minus pi h. That will be our f at x, grade 12. Into our formula, f derivative of x. What is f at x plus h now? This is the limit of h approaching 0. F at x plus h is pi minus pi x minus pi h. Minus our f at x, 2 times important bracket, pi minus pi x. Everything over h, grade 12. Do not forget that important h. Continue, limit of h approaching 0. We want to deal with the bracket now. That is step 2, remember? And then we have pi minus pi x. This one will remain as they are, the pi h. And then negative into that bracket. That will be minus pi. Negative by negative will be positive pi x. Everything over h. Remember that magic? That your f at x will all disappear. Pi x minus pi x cancel. Give us the 0. Minus pi plus pi, 0. Sign must be opposite. Same things with opposite signs. Okay, they give us a 0. So we are left with what now, grade 12? Limit of h approaching 0 of minus pi h over h. Look at that now. The h will cancel in h. What is left? Minus pi. No h, no limit of h approaching 0. So look at the answer now. Is our prediction correct? Yes, grade 12, 100% correct. And then allocation of marks for this particular problem. 1 mark will be for the correct f at x plus h. Number 2 for correct substitution into a correct formula, grade 12. Number 3 will be for simplifying that bracket. Number 4 for cancelling h. Number 5 for your answer. So this were 5 marks, grade 12. For all first principle, we are having the 5 marks. Okay, moving on to the rules now. Let's take the 3 application of rules. Remember, with the rule now, there are things that you must check. Number 1, the no-go area. You must not have brackets. You remove brackets before you derive. Number 2, you remove all the sets and write it in exponential form. Number 3, no variables on the denominator. I hope you are still together, great jobs. Okay, now let's look at the number 4 that we are giving. Number 4, we have a variable x in the denominator and something is added to that. It says 1 plus x. Okay, and then how are we going to get rid of this 1 plus x now? Grade 12, the misconception is that most of the time you take 1 plus x and take it to the numerator and write it as 1 plus x to the power minus 1. You can't do that if you're having a binomial. Binomial is 2 terms. Ne? If you have 2 terms on the denominator, you can't move to the top. In this case now, we rather rely on the factorization because we see on top we are having a trinomial. Let's see, can we factorize this trinomial now? Okay. Factors of 1, it will be 1 and 1. Factors of 2 is 2 and 1. That means it will be 2x and an x there. Okay, because everything is positive, this will be plus plus. All right, this is working for us. Can you see now it has created a 1 plus x? Therefore, the 1 plus x will cancel 1 plus x. So we are left with f at x, Richard. We are still at f at x. We have not yet started deriving. We were simplifying. So the minute you simplify, the notation must still be original f at x. Now at this level now, because this is now simple, we can now derive. The minute you derive, tell us with the notation, change the notation to a derivative to show us you are deriving. Remember the derivative of a constant number is 0. So this one will give us a 2. If it is x to the power 1, you only take the coefficient. Therefore, that is your answer for that particular derivative. Happy? So this problem will worth 2 marks, 1 for the factors, and then 1 for the correct derivative. That is 2 marks. Look at number 5, grade 12. Again, the no-go area. Okay, let's check. Oh, we have variable in the denominator. We can't derive before we deal with this variable. No variables on the denominator. Okay, let's check, grade 12. How are we going to remove this one now? Okay, it's only one variable, which is x cubed, okay? And then it's not the same as the case that we are having there. I'm trying to clarify the two. In this one, we factorize because we're having a binomial on the denominator. In this case, we are having only one term, x to the power 3. So we are going to separate this now and show that each term is taking the denominator x cubed. Can you see now? We are able to share each top is taking the denominator x cubed. Why are we doing this? Because our denominator is one term. You can't do this when you are having a binomial. Okay, look at the notation. I am continuing writing dx because I am simplifying, not yet deriving. Okay, continue with dx now because I want to simplify this. Here we are applying the rules of exponent. When you divide the same base, you subtract exponent. That means it will be x to the power 1 minus 3, which is minus 2 greater. Same base, subtract exponent. Divide, same base, subtract exponents. And then here again, you have x to the power 2, x to the power 3. Same base, you take one base. 2 minus 3 because we are dividing. That is minus 1. Happy now, everything is on one line. We can now start deriving. The minute we derive with this notation, grade 12, you don't write that dx anymore. Notation, please. That will be minus 2 times 1, which is minus 2x. Subtract a 1 from the exponent, minus 3. That is the rule. And then negative 1 times negative 1 here. That will be positive 1. And then x minus 1, that is minus 2. That is the application of rule. Therefore, this is our derivative, grade 12. And then if we want to get rid of the negative indices, because sometimes the examiner will say all your answers must be in positive exponents or indices. So you need to take this one because it's the one that is affected by a negative exponent. It will be minus 2 over x cubed. Plus we have 1 on top. This one that is negative is the one that will go below x squared, grade 12. Okay, the last one. Last one for the day. Can you look at the application again? There's a similarity between the two. They are both having a variable in the denominator. Okay? And then if that is the case, in this case, we have two things now. We have a variable in the denominator. We have a root sign there. So it's a third. When we talk third, we take square root, cube root, and so forth. Okay, so we need to change that grade 12 before we derive. Let's do so. We have S at T. Since we are busy simplifying, we don't indicate derivative on the left. We write the same S at T as it is given there. So now this square root of T, we write it as T to the power of half grade 12. Remember, there's a 2 there, sign only, therefore it will be 1 over 2. It is not written there, but we know there's a 2 for square root, and then that minus T there. Right, remember now the denominator, if it is 1 variable, you will share equally to each term. Therefore, this will take over T and also that 1 over T. Happy now, grade 12? Let's continue with the simplifying. Simplifying, not yet deriving. We are dividing the same base, we subtract exponent. Remember, this is to the power 1. It will be half minus 1. Same base, T, and then half minus 1 minus half. Minus T divided by T1. Or if you want to take exponent, same base, it will be T1 minus 1, which is T to the power 0, still 1. Okay, now we can now derive derivative of T of S in terms of T. That will be minus half times the 1 there. That is minus a half. T to the power, you minus 1 on the exponent. That is minus 3 over 2. Constant number is a 0. Okay. And then now, if you want to get rid of the negative indices, remember we have minus 1 over 2. We have a denominator already, which is 2. You can't create another fraction per 12. You will just take this part here, T to the power minus 3 over 2, and take it to the denominator. Then it will change to positive 3 over 2. Thank you very much, grade 12. This brings us to the end of today's session. This lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Good luck with your paper 1. All the best, grade 12. Bring those distinctions. Bye for now.